Good morning, and welcome to the Power of R&D Partnerships Advanced Materials. My name is Judy Thal, and I work for NISTAR. NISTAR is Empire State Development's Division of Science, Technology, and Innovation, and we fund the Centers of Excellence and the Centers of Advanced Technology that we'll be presenting today. Our first, our first panelist is Alan Ray. Alan is the director of the New York State Centers of Excellence and Advanced Technology at Buffalo. They have two centers of excellence and one center of advanced technology. And the Center of Excellence that Alan will be representing today is the COE in Materials Informatics. So, Alan, if you can come to the stage, that would be great.
Morning, Judy.
Good morning, Alan. How are you today?
Good.
Good. Well, let's get started.
Mm-hmm.
How would you define advanced? What makes a material advanced and therefore of interest to you?
Well, there are a number of categories. You can have new materials that are going into new applications. So, for example, superconductor materials going into quantum computing. You can have new materials going into existing applications, like graphene composites going into lithium-ion batteries. And then you can have old materials going into new applications. I recently learned that one of the developing applications is to put balsa wood, which many of us used to make model airplanes when we were a lot younger, into wind turbine blades.
Wonderful.
So there's a wide category.
Okay, and since the center that you're representing is the Center of Excellence in Materials Informatics,
Mm-hmm.
what does materials informatics mean?
Yeah, when I say materials informatics, it usually produces a blank stare with people. So basically, it's the use of data-driven methods to help improve materials, either the development of materials, the use of materials, the processing of materials, or the, if you like, the life cycle assessment of materials. So it's any aspect of data and materials.
Thank you. How would someone know when to reach out to you? And are there specific criteria a company need to meet in order to begin a discussion with you and working with the center?
Okay, so we don't do basic science. So basic science in the universities is generally funded by NSF or NIH. That often provokes ideas that may develop into products, and either the faculty has made an invention disclosure, or they have a relationship with a company. They may come to us to do a partnership to say, hey, this is something that we think has real potential and our partner thinks has got real potential. So we have a rubric that we use to choose, is it going to have economic impact? Is it going to be something that's going to make a difference? It's not, we don't do blue sky science, we don't do product development, but it's, if you like, the blank area in between those that we help support with our grants. We normally support companies to the tune of $50,000, and they sometimes come in and they will match that funding, or in fact, overmatch that funding when they've got a project that's exciting to them. And then it moves on to the next stage with them go with the company either licensing the technology, or if it's a startup, they may go to SBIRs or other grant applications to take it to the next stage.
And when you say that you fund them, is this you fund them? How do you fund them? What does your funding cover?
We fund the faculty to do the work with the company. So we fund the faculty, and we also support students doing internships on these projects as well.
Great. What types of projects would be a good fit?
Well, materials is a pretty broad area. If you look at the kind of projects they've involved, it's been everything from quantum computing materials to mycelium from fungus to be used in packaging and air filters. The projects that we're supporting this year include graphene derivatives for lithium batteries. We're also looking at, we've been looking at projects for, gosh, a whole lot of areas. The degradation of zirconia dental implants. They fail a lot sooner than they should. And so basically looking at the modeling and the analytical work on that. The use of new antennas to use citizens bands radio for low-cost internet for disadvantaged areas. So, for example, the fruit belt around the incubator in downtown Buffalo is a disadvantaged area, and this is a way to get cheap regional internet to people. So, really wide range of applications.
Okay. Can you give an example? I'm sorry?
No, go on.
Okay. Can you give me an example of advanced materials success story that helps demonstrate the type of expertise the center brings to a project?
Yes. So we've been working with a local company that does thermal transfer materials. So thermal transfer materials, if you can think about it in terms of industrial applications of the kind of technology that you use for iron-on t-shirts. So basically, you can digitally print patterns. And so we've been working with a company that has been using very thin aluminum for thermal transfer for making RFID tags. And the advantage of that is it uses 1/100th of the material that's used in the normal production of RFID tags. So we partnered them up with our wireless group here in University of Buffalo and developed antennas. And normally with RFID tags, they work within just a short distance. We've managed to do this so that they're working over distances of over 10 meters. So you can imagine this helps to enable things like walking out of Wegmans with your shopping basket and all your purchases can ping the cash register and you spend the money before you've even realized you've spent it. So it's a really exciting for warehouse applications, and you can print these actually on packages. You don't actually have to put a device separate inside the package.
Oh, I
Fun
like the idea.
It's continuing for a second year.
I like the idea of making anything grocery shopping easier.
Yes.
So, and quicker.
Yes. Cheaper. We'd like to work on cheaper, but we haven't got there yet.
That would be really great. What are some of the more challenging materials projects you've worked on? And how are advanced materials making an impact?
Well, one of the challenges is, finding defects. So you really have to look at, identify, figuring out what a defect might cause, how you'd need to look for it, whether it be atom probe microscopy, it could be ultrasonics, it could be eddy current, especially in areas like 3D printing, where, people are starting to use 3D printing for critical applications like hip joints and things like that. We got to find ways to do non-destructive testing that will work. And that involves, experimentation. It involves a lot of modeling, interpretation of the results. So if you like, the non-destructive testing is a really big challenge for composites and airplanes, all kinds of areas.
How important is AI and access to advanced computing resources?
The answer is it depends. So my Toyota recognizes street signs. So that is using AI for image recognition. And AI is really a whole grab bag of different tools. It can be speech recognition, image recognition, natural language processing. So there are a whole lot of tools. And some of them can be done on a relatively non-powerful computer, but some of them really require heavy-duty computing. And so that's where we work with the Center for Computational Research, which is in the basement of the building and has a supercomputer cluster, which is both an academic cluster and a business cluster. So we have a number of businesses that have been using our cluster, for example, to do things like predictive maintenance of wind turbines. There are others that are in the medical materials area that are doing various kinds of simulation. So we make that available to our local industry.
And one more question. How do you have any suggestions of support that companies can look for to help them pay for the program, for their portion of the assistance through the center?
Okay, so we've been fairly successful in leveraging Fuse Hub grants as follow-ons for the projects. So several of the clients that we've worked with have received Fuse Hub grants, which helps them take them to the scale-up stage after where we are. We also talk with people, we work with people on their pitch presentations for investment, and also, we support them with their federal grant applications.
Great. Well, Alan, thank you so much for this. And anybody that has questions for Alan can find him after the presentation. He has a University of Buffalo and Alan have a table set up. And so you can join his table and ask him any questions.
Okay, thanks, Judy, and look forward to talking to all of you. Okay.
Thanks, Alan.
Bye.
Bye. Next up is John Sinnott. John, program manager at CCMR at Cornell, and CCMR is Cornell Center for Materials Research. Morning, John.
Hi, Judy. Can you hear me?
I can.
All right.
So let's get started. I'm going to ask you the same questions that I asked Alan. I imagine everybody has different answers to these questions. How do you define what makes a material advanced and interesting?
Sure. So I guess an advanced material is really one that doesn't really exist in the natural world. And Alan touched on this, computationally designed materials that enhance the functionality of a material, or maybe it's the convergence or integration of a biological and a structural material, or it could be a material that self-assembles, or a tailored interface that produces a nanocomposite. And I guess a common thread in all advanced materials is in understanding the nanoscale or the microscale mechanisms in a material and how they relate to those macro scale properties that they exist. And that understanding happens through theoretical and experimental work. And Cornell is a leader at envisioning and synthesizing new materials, at the molecular or the atomic scale. And I guess what I find interesting is, applying these made-to-order materials in ways that solve challenging problems that we face as a civilization, whether that be energy production or storage, or fighting pandemic-related supply chain issues, or preventing these forever chemicals from entering the environment.
How would someone know when to reach out to you? And are there specific criteria that a company needs to meet in order to begin a discussion with CCMR?
Well, I guess first I'd say, don't be intimidated by the size or reputation of Cornell. The Industrial Partnerships group here at the CCMR is here to be that interface between companies of all sizes and and the variety of world-class faculty experts at Cornell. And the Cornell community is really full of curious people who love to solve hard problems. I mean, look, we can't all be physicists or chemists or engineers or biologists. So I'd say bring us that hard problem that you're not an expert in, and let us, find an expert in that field for you.
And I can attest to that all of our centers deal with very small companies, startup companies, all the way up through very large companies, and all are each project is given its due. And yes, okay. What types of projects are a good fit for CCMR?
Well, so let me start, since it's a short list, by things that we don't do. We're not in the software development business. We can't help, write that killer app for you. We're not business development advisors, so we're not going to be developing your business plan. But if you can touch it, we can probably help you. We're really good at characterization and imaging materials, down to atoms if needed. We can help develop new quality control and test methods. We're good at testing and validating new technologies. And we can help develop or modify materials for a variety of applications, from culinary and medical to electronics, high fashion, even farm operations.
Well, on that, can you give an example of an advanced materials success story that would help demonstrate the type of expertise CCMR brings to a project?
Sure. I guess if I had to choose one, I'd choose one that comes from a company that manufactures medical devices that enhance the visibility for the surgeon during minimally invasive surgeries. The device is basically an egg-shaped plastic wand that has a fluorescent dye embedded in the polymer. And the device glows when it's placed under near-infrared light used during these surgical procedures. And the manufacture of the device is done with injection molding. And during that molding process, the polymer with the fluorescent dye is subjected to high heat and pressures. And this process was causing the device to suffer from inconsistent fluorescence intensity. So the CCMR helped by enlisting the help of a polymer chemist who solved the problem using two different strategies. First, they worked to encapsulate the dye in a composite filler material that protect the dye molecule against thermal and chemical degradation. And then second, they worked with a local dye manufacturer to basically alter the hydrophobicity of the dye to reduce the fluorescence quenching in the plastic resin. And now this process is used in production of medical products for gynecological and urological surgeries.
Terrific. Wow. What are some of the more challenging material projects that you've worked on, and how are advanced materials making an impact?
Oh gosh, that list is long. I guess like a lot of people, we helped with working on the development of microfluidic devices for rapidly detecting COVID-19 viruses. We've worked with a small company to teach them how to use scanning electron microscopy to validate their software product that detects malicious circuits hidden in microelectronics devices that pose security risks. We've worked on the development of textile fibers used in ballistic protective vests that can absorb toxic fumes produced during an arc flash event. We helped develop an X-ray fluorescence standards for material screening and verification for the RoHS compliance. Oh gosh, we've worked on the development of quality control methods for analyzing wool and cashmere fibers basically to prevent counterfeiting. It turns out there's something like 10 times more cashmere sold than is produced every year. And, Alan mentioned life cycle assessments. We're working with a company right now doing a life cycle assessment, comparing the net environmental impact for a new medical gown made from biodegradable fabrics relative to, gowns made from standard polypropylene materials.
So you're all over.
Yeah, I could keep going probably, but time is limited here.
And lastly, companies that are interested in working with CCMR, are there programs to help support their costs?
Sure. We have a number of matching grant programs that can be used to fund applied research projects. I know our flagship program is called Jumpstart. These are short-term collaborative projects with university researchers, really designed to solve a specific technical challenge. The CCMR can provide up to a third of the funding, up to $5,000, and we can co-sponsor MEng projects. We can supply supplemental funding for Center for Advanced Technology projects awarded at the Cornell Life Sciences CAT. And we can support the summer salaries for Cornell student internships as well.
Now, the Jumpstart program, is that an ongoing program, or does that run at different times during the year?
No, that is a competitive process, and we take applications twice a year, beginning right before the start of each semester. So we've collected applications in June for projects that will kick off in September here, coming right up, and we'll collect applications again in October for projects that will begin for the spring semester in January.
Great. Well, thank you so much, John. We really appreciate it. And again, to our audience, John will be at, he has a table, a Cornell table, and you can meet him after the event there and can ask him any questions that you have.
Thank you so much, Judy. I look forward to speaking with people.
Next up is Ship. Devin is the director for the Center of Advanced Materials Processing, or CAMP, at Jackson University. Good morning, Devin.
Hi, Judy.
How
are you? I'm
great. Great. Okay, so how would you define an advanced material? What makes a material advanced and of interest to you and to CAMP?
Mm-hmm. So this is an interesting question, and both Alan and John have given very correct answers. I'm going to take a slightly different tact and say, I think something that's advanced is going to advance the product or advance the application. And to give you an example, polystyrene, for example, is around a long time. Like it these days, it has its own uses in some areas.
Devin, you're cutting in and out a little bit.
Cool. All right, sorry about that. I don't know.
That's perfect.
This maybe if I speak a bit slower. So I was suggesting that advanced materials is something that might be seen in the eye of the beholder, whether it's advanced or not. So something like polystyrene may not be advanced in a styrofoam cup, but that type of material could be utilized in maybe nanostructure.
No, Devin, I'm sorry. You're going in and out again.
All right. So maybe if you want to switch to another speaker, and maybe my bandwidth may improve over time.
Okay. All right. I will move on to John and then come back to you. Is that okay?
Yep.
Great. Okay. So then I'd like to introduce John Simmons. John is the Executive Director for Research and Economic Development at Alfred University, and he is representing the Center of Advanced Ceramic Technology. Morning, John.
Good morning.
Can you put your camera on?
Yep, there we go.
Great. So, how would you define advanced material? And maybe it's different because you focus more on ceramic, or maybe you would define it similarly to the way others have defined it this morning. And what makes a material of interest to you and to the CAT?
Sure. My perspective, and Alan touched on it a little bit when he talked about old or traditional materials that are now getting a new application. That's what I found really fascinating in the last couple of years. In an example, silicon carbide. If you go to the McMahon Engineering Building at Alfred University, there's an absolutely massive grinding wheel sitting out in front as kind of a decoration. And that was made by Carborundum back in the day, and it's made of silicon carbide. And, back 50, 60 years ago, we were working on silicon carbide for grinding wheel grit technologies, et cetera. Now they've got a entirely different life in as a leading edge material in hypersonic vehicles. And so we, are using a lot of the same analytical technologies as we would have done decades ago to look at the old material in a new way and try to figure out new processes for affixing silicon carbide onto leading edges for hypersonic vehicles. So that's the kind of stuff that I find fascinating, having actually gone to school at Alfred University a long time ago. It's kind of as much as things change, they stay the same. Another application is mullite, which when I was in school was a product of the decay of a clay upon heating, and now it's being talked about as a window material in hypersonic vehicles. So you don't really get away from these materials, just constantly reinventing them. And I find that very interesting. Now we are doing a lot of new stuff, borderline basic science stuff. You really got to know the science in order to make the product. And we have working with a couple of groups that are using ostensibly new materials to create energy storage devices to rival batteries, materials that are a lot easier to work with than, say, the materials in lithium batteries, but they are capable of having similar charge densities and also similar cycle rates. So you can cycle these things over and over and over again. And that is really very new materials that we're looking at. And I don't want to spill the beans for the two companies, but it's really fascinating stuff.
Great. How would a company or an individual know when it's time to reach out to the center, to you? And are there specific criteria for a company that they need to meet in order to begin a discussion?
An awful lot of what we do is performing analytical services for companies that don't have that capability. As companies tighten their belts more and more, they kind of cut back on research and development resources, and especially rather expensive analytical devices. And we found that we can really step in there and help companies with that. We have a number of different types of agreements, kind of a short-term, medium-term, long-term. And as far as the long-term goes, we're getting involved with companies more and more and really acting as kind of an outsourcing resource for them, where we are their analytical laboratory. and become very involved in their production issues and helping them provide those services that they can provide. Another way is that we've developed a ceramic pilot plant in the incubator in Alfred. And that pilot plant, again, is there because companies have been cutting back on things like pilot plants in order to be more profitable. So it's, you've heard of, CFO in a box. This is kind of pilot plant in a box. And companies can come in and we have a very simple agreement for them to utilize this equipment and try out new techniques and new technologies. And so if a company gets to a point where they aren't sure if they can go any farther with the analytics that they have or the processes they have, then that would be time to reach out to us.
What types of projects? I mean, I think you touched on this a little bit. It kind of seems like a large scope of projects, but what types of projects would be a good fit for your organization?
Well, again, Alan and John mentioned that when you're talking materials, there's an awfully broad application. I mean, ceramics are found in literally everything. So our projects, again, can go from the biomedical materials arena to hypersonic space vehicles, to other harsh environment applications. It really depends. And as I alluded to earlier, you could have the same material into completely different kinds of projects. But we get a lot of projects. Alan, I saw in the notes, Alan was talking about rare earth recovery. We are working with Alan and with a company that's just down the hall from us in the incubator in Alfred to do rare earth recoveries in thermal barrier overspray. And we've been working with that company for 30 years. They develop technology and then they license it or sell it. And they're on their third or fourth iteration now, and it's rare earth recovery. So the different applications are literally the sky's the limit. We get all the time, and I see in the comments, do you know anything about this? Do you know anything about that? And those are the kinds of inquiries that we get, and we're always amazed at what the applications are.
And can you give us a success story that might help demonstrate the type of expertise that the CAT brings to a project?
Well, the rare earth recovery project was very successful. Another project that we did was with Freeform Fibers, which I think is out of Saratoga. Anyway, they were looking to scale up. They had a great product. They had a great technology, but they were looking to scale up. So we helped them with that, and we got them going in a scaled up production environment. And that resulted in a significant influx of equity funding, which they're going great guns now. They're doing great. So there's that. We are working with a company that has some new technologies. They were looking at Pennsylvania, they were looking at Indiana, they were looking at New York. And by working very closely with them, they're going to relocate to New York and build a plant just across the street from the incubator in the industrial park there. And they should be very successful at what they're doing. They've got a great product.
That's a great story. I'd like to hear ones where New York wins.
That's our sweet spot.
What are some of the more challenging materials projects that you've worked on?
Well, I can mention one right now. It's a window material for hypersonic applications, where they want transparency in radio frequency and IR and UV, and those are three very different sets of frequencies. But we found that with picking the right material and the right microstructure, we can kind of sort of get them there. And they're willing to, if we provide them with a material that isn't going to degrade or just outright melt while doing its job, they can adjust what we give them as far as transparency goes with the electronics. So that's a very challenging thing to do. And we're still working to perfect that. And we're looking forward to putting that into some aircraft in the very near future.
Exciting, yes. And lastly, are there programs that you suggest to companies to help them pay for their projects with you, the assistance that they're receiving from you?
Yes, besides the standard, we do a standard cost match with them, anywhere from 10% to some companies all the way up to 50-50. But we also try to get them involved with Fuse Hub, and we've won, I don't know, a half dozen awards in the last couple of years. We get them involved in SBIRs, STTRs. We get them, put them in touch with the MEPs and with the local Empire State Development folks. We put them in touch with our landlord, the incubator, and they have their whole series of projects and programs. And we also have a kind of a Rolodex of venture capitalists and non-traditional lenders that we can introduce them to help them kickstart. We also have been known to loan them our space. The pilot plan is an example, and help them develop their process from a tabletop process to a pilot plant process, which would then give you some degree of comfort that you could scale up to a full factory production kind of environment. So we've got a number of different ways of helping them. Some people only need one, some people need 3 or 4. So it's always an adventure to find out what the needs are. We've also reached out to manufacturing companies in Allegheny County, which has been a very underserved county. And we help them, we tell them about resources that are available to them, even though they might not all be glass and ceramic companies.
Wonderful. Well, thank you, John. I really appreciate you being here this morning. And John will be at the Alfred table after the event. Hopefully, after we get Devin back and he speaks, then we will go to just the networking portion. So look for John. Thank you, John.
Thank you, Judy.
And now if we could call Devin back up to the stage, hopefully.
All right. I am back. Am I sounding clearer and a little less jagged?
Yes, you are.
What?
So
Right.
I think if we could just maybe start over and how you would define an advanced material.
Yeah. So, and it to me, the previous speakers have given great definitions for an advanced material, and as they've indicated, materials are or can be found in absolutely everywhere, and often they're very advanced in terms of the how much is known about them or how recently they've been developed. But I think one interesting way to define an advanced material is whether the material advances the product or advances the company's mission in some way. So one can take an older material, silica, for example, which has been around a long, long time, and use it in an advanced application like semiconductor manufacturing or something like that. So to me, an advanced material really is whether it's or maybe not advanced is in the eye of the beholder. And really, I think it boils down to the company that's using it and the application that they want to put that in. So at camp, we don't sort of sit down and think, well, this is not a new material or it's not a novel enough material. We look at what the application might be, obviously work with the company on that, and then determine sort of the path forward. Usually if a company is coming to us to have a discussion, there's an issue or some problem or something they want to further understand or develop. And you almost by definition, the fact that that outreach has happened and that connection is made makes it an advanced material.
I like that answer. How would someone know when to reach out to CAMP? And are there specific criteria a company needs to meet in order to begin a discussion or start a project with CAMP?
There's no criteria, and in some ways, I think the companies themselves would know if they're not got the facilities or the expertise in house in order to solve a particular problem. Often they know exactly what the expertise is, they just don't have it. Sometimes they're not sure if they do have that expertise or not, and perhaps it's a bit of a gray area. But I think any of those kinds where you're asking that question, well, do we have it? And I'm not sure, or I definitely know that we don't. That would be a time to reach out to a CAT and say, look, these are the kinds of things that we're facing. What do you know about this area? How can you help us out? Or can you get us connected with someone that may be able to assist us with that particular area? And I think this has been inferred by some of the other panelists, but often these initial discussions end up sort of unearthing some either different types of problems or go different directions. And so anytime that you can get together and have a conversation about a particular an issue or problem, usually that's always a good thing, I think, in that you're able to identify what you know, what you don't know, and then potentially look for solutions.
So sometimes a company may come to you thinking that it's one issue, but after a discussion with you may find out that it's entirely different.
Exactly, and that the solution may be something that our faculty and students might be able to solve. Ideally it's fairly quick, but maybe that's just because of the expertise or the equipment that we might have that's not available in-house in the company, or maybe it's much more complicated and it's with the project is going to be a much bigger task, and then we have to sort of divide it up into something that's either bite size, or the company has to decide maybe this whole project is just not going to move forward and we have to make a decision to sunset it or something like that. But at least there is movement and there's a decision that gets made.
What types of projects, and I think maybe you touched on it, that you work on all different types, but are there any really projects that would be a really for CAMP?
Yeah, so CAMP's faculty, there's probably 40 odd faculty at Clarkson, and along with their graduate students that are actively engaged in CAMP activities with companies, and both New York State and non-New York State companies. And they range in a wide sort of all across the gamut in terms of the types of materials and the types of things that they do. So our name is Advanced Materials and Advanced Materials Processing. So we have faculty that work on new material synthesis, novel materials. It could be polymers, it could be composites, colloids, surfaces, particles, nanoparticles, and so on. Or it could be the processing of those particular materials. Sort of, additive manufacturing might be an application. It might be an energy application, environmental or biotech applications. One of the areas that we have particular strength in is something called chemical mechanical planarization, which is a technique that is common in the semiconductor manufacturing business. So it's basically planarizing a surface down to atomically flat surface over a 300 millimeter wafer. And that technique, while we don't do the semiconductor manufacturing at Clarkson, but the CMP technique takes a colloidal slurry and a polymer pad, and basically it's a bit like polishing your car, I guess. And one has to have a deep knowledge of how the particles interact with the different surfaces and with the carrier solution, the polymer pad that's involved, pressures, there's chemistry, there's all sorts of things that go on. So there's a wide range of different areas of expertise that we have, and we engage with all sorts of companies. So there's startup companies in the CMP area, and then there's very established, users of CMP, the big semiconductor manufacturing chip fabs in New York State utilize Clarkson's expertise area. So the projects are a wide range. The company size is wide ranging, and we aim to help every single one of them maximize their interactions with us.
And I ask this because Clarkson is in the North Country. You said that you deal with all different varieties, and I am assuming that you deal with companies from all over the state as well.
Yeah. So while we're up in the north, St. Lawrence Valley, and we got great hiking in the Adirondacks we can get to. But we work with companies all over the state. So from Long Island all the way over to Buffalo, and then up here in the North Country, Plattsburgh. So quite a wide range geographically, but also size-wise.
Can you give an example of a material success story that would help demonstrate the type that CAMP provides?
Yeah. So I'll go back to the CMP example, just because that's sort of been a sweet spot for many Clarkson researchers. So a company in upstate New York, in the Syracuse area, has developed, worked with Clarkson faculty to develop a new CMP slurry. This was commercialized several years ago, but really to be able to develop that slurry in-house was not possible by the company. What they were able to do was utilize Clarkson's the knowledge and the experience of working with those kinds of slurries to understand removal rates, defects that might appear because of the slurry during the production, and be able to sort of tailor it so that the slurry itself not only had the performance that was desired, but also had things like shelf life, fundamental things that are important to a production in order to be able to sell the product successfully. So that's one example. There's lots of other smaller ones. The more recent one with Estee Lauder have worked with us. This one hasn't quite hit the shelves yet, but they're working with one of the chemistry faculty to be able to let's say make things like sunscreen last longer before reapplying. So those kinds of things are of interest to materials that just sort of, I guess, everywhere. We can think of them improving our lives and reducing, I think, an environmental impact in that particular case, so it doesn't wash off and end up in the oceans. That's an important factor. Sustainability as well.
What are some of the more challenging materials projects that you've worked on, and how is Advanced Materials making an impact?
Mm-hmm. So, all these wouldn't be challenging. If they weren't challenging, then I guess we wouldn't be doing these kinds of projects. But I'll call on one that involves a company that's looking in the aerospace and aeronautical industry. And so one of the problems faced there is, sort of what happens with materials over time. So do they degrade, do they fatigue, all those kinds of things. So doing fatigue testing is not easy because one has to have a lot of time and effort of pushing and pulling and bending the material. And so one way to overcome that is to develop models, to do experiments under the conditions necessary in order to then start to model the response of the materials. And in this particular case, there's some extreme environments involved. So one has to be very careful about how you do those experiments and then develop a model that would help you predict what the behavior of the material will be. So those sort of a combination of things, the time it takes to do those experiments and the extreme conditions, and the fact that a lot of these models simply don't exist at the moment, and be able to predict, prediction quality then becomes a bit lower. That's all very difficult, but my understanding is that the company is very, very happy with the response that they've got from the faculty research. Expect that to be able to have some far-reaching impacts in the aerospace and aeronautical industries.
And last question.
Mhm.
What are there programs that companies can avail themselves to help them with the cost of working on these projects with CAMP?
Yeah, so we have a couple of different things. So Clarkson has an incubator, like most universities do. So the Shipley Center at Clarkson is always there to help, especially for smaller companies. So it helps with both operational costs, but also space, rents out space and so on to smaller companies. We faculty at Clarkson are always willing to talk to companies that are wanting to be writing SBIR type grants. These are typically federal monies that we can go after. Internally, we have a couple of programs. So if a company and a faculty member are willing to get together and can write a short proposal, we get that reviewed, and that allows the company to get some preliminary data through the use of a grad student to do some of the early work. So we have a CAMP fellowship, that's called. So we have a couple of different mechanisms in which people can get some funding to get things moving along, and but we're always willing to sort of work with, if the company has other avenues, we're always happy to sort of help out with writing letters of support and so on to be able to make those avenues open up.
Well, thank you, Devin, for being here this morning. And for the audience, Devin will be at the Clarkson table. If anybody would like to talk further with him, you can just meet him at the table. Thanks, Devin.
Thanks.
And so that concludes the event portion today. Thank you all for being here. We hope that you found it helpful. And I think that as our presenters discussed, you can go. You can go to one center, and if they are not able to help you, they will. They can put you in contact with another center, or you can contact Fuse Hub, or you can contact NISTAR, and we can also help you figure out which centers might be of the most help to you. So again, thank you. Please take advantage of the networking portion of the program.